University of Split in Croatia, and I will present our work on intelligent wildfire surveillance and management system. This is actually a production system used by firefighters in Croatia, and we have very positive feedback. This work started as a seminar paper on my postgraduate study, and after first results we went to firefighters, asked them what do you need really, is that can this be useful for you, and so on. So I will skip motivation, it's pretty obvious, and just share with you some specificities of Croatian coast. First one is that we have a lot of small villages, mid-sized towns and so on, scattered on the coast and on islands, and they are usually surrounded by dense pine forest. And another significant thing to note is that we significantly grow in population during summer months, which are also the main fire season, and it can be 10 to 15 times even more when compared to winter population in that area. And we have also some separated points of human activity, like auto camps, like also as a consequence of tourism, like auto camps, like picnic areas, people hiking through mountains, forests and so on. And as usual, all of this has some consequences. We have bad news and good news. Bad news is that practically the entire area, coastal area and islands, are wildland-urban interface, and this makes fighting forest fire more difficult and preventing it more difficult. But there is also one good consequence, that is that there is a very high probability that all fires, all incidents will be reported very soon. Actually, when we first time talked with firefighters, they told us, okay, it will be great if you can provide early detection, but early detection for us means minutes, 2 minutes, 5 minutes at most, because, and that was back in 2004 or 5, because they have statistics, and they told us that almost all, if not all, fires are reported in first 8 minutes from ignition in Croatia. Because of that you have anytime, anywhere, someone will be looking at direction of incident and the fire will be reported. But they told us, okay, any minute would be great, minute earlier, but if you could provide us with a way to confirm an incident and to locate incident, it would be great. So video presence, in the case of real incident, would be great, because they can use that to precisely pinpoint location of the incident, and they can use also video presence to guide intervention in more efficient, more safer way. So, and any other data like geographical information, maps, directions, roads, better data will be very useful. So based on this, we call this Tribor, but now it is sold under the commercial name OIV Fire Detect AI. OIV is Odašiljači veze, state-owned communication company controlling critical communication equipment like infrastructure, like TV signal, like communication towers and so on. And basically they provide all infrastructure needed, from towers, from connections, electricity, cameras, even cloud-based hardware resources for our program. And we provide software, and in cooperation with them, intelligent wildfire surveillance and management system was developed. This is a glimpse of system interface. This is basic interface. Operator has to control the system, and in the controlling centers they have video walls with many monitors, and they can control our cameras, but this is the controlling terminal for an operator. So system has several functionalities. It is built around early detection. However, this is not the only functionality. We provide video presence on remote locations. Actually, now we have more than 70 locations, 74 I think locations in Croatia, each one equipped with 2 cameras watching in different directions. They use video presence for alarm confirmation, for remote management of the intervention. System is closely coupled with GIS information, and we use that information in a detection phase to provide more accurate detection. But this information is also used to provide firefighters with information they need to guide an intervention, like roads, terrain surrounding. We provide simulation of fire spread based on real-time meteorological data or manual entry data, manual entry like wind speed and direction. fire risk assessment. For those who were listening to Marin yesterday, he gave some information about that. And one last thing to note, this is not desktop application, this is cloud-based solution, so practically anyone with appropriate credentials can access the system and use the system. We have operators in controlling centers with many monitors and many cameras. However, I don't know, field commander can access the system using his mobile phone, or someone in Ministry of Interior Affairs or Ministry of Defense who also have access to this system can control system, or maybe some commander of high rank can access the system using any hardware basically that has a web browser can be used to access the system. I will start with maybe main functionality, early Wi-Fi detection. As I said at the beginning, we must detect, or at least it's expected from us to detect fire in the first few minutes, at most 5 minutes from the ignition. We deal with some obstacles like expected distances up to 10 or even more kilometers. However, main obstacle or main complication is very low quality of images. This is not due to low quality cameras. This is due that these cameras operate in harsh environment 24 hours a day through the whole year, and we have degradations of image quality due to camera shake, dust in the air, sunlight effects and so on. And smoke is often very, very hardly visible. And what is not visible, it is hard to detect. So I'll give you 2 examples. This is what we are dealing with. This is maybe worst examples. There is not always a situation like this. There is a real fire, beginning of fire in both of these images, and I guess you cannot see it on either one. So even in this situation, when we cannot detect fire, smoke on these images because no one can see it, and the computer can also see it. But even in this situation, system proved to be very useful because when someone reports fire, operator can stop automatic detection, zoom on the area and confirm if that is a real incident or some other phenomenon like dust in the air due to some construction work or something like that. So basically, standard procedure is shown on this slide. When system detects an alarm, detects possible smoke, or if someone calls and, for example, in this situation and told the operator there is smoke there, operator stops camera. This is a real incident, I think, from 2021, 31st of July 2022. Operator stops camera, stops automatic mode, zooms on the location. We have cameras with up to 32 times optical zoom, and to confirm that there is a real forest fire, and starts procedure for intervention. So next step is to precisely pinpoint location of the incident. And basically, as our system is integrated with GIS, we know exact location of each pixel in the field of view of the camera. And only thing the operator has to do is to click on the camera, on the image from camera, and the exact location is shown on the map. So it can then zoom on the map, see the roads, surrounding terrain and so on, all the information which can be useful for firefighters. So this tool requires some experience, because if you click maybe below or above this hill, it can be kilometers away. However, experienced and trained operators use this tool very efficiently. We know some other information about each pixel. We know exact distance of each pixel for camera. For example, this pixel here is 688 meters from camera. We know area of which is represented by each pixel. We know outline terrain and so on. So all of this information can be useful to firefighters, and some of this information is used to improve detection efficiency. Next step, when you know exact location, next step is to start fire spread simulation. We use propagator, and this is basically a click operation. Operator just clicks on the propagator, and simulation is started based on real-time data collected from DHMZ. DHMZ is State Meteorological Service in Croatia, and simulation started based on real conditions. Actually, when we first developed propagator, it was used in a way that operator has to manually enter wind speed, wind direction, so on, humidity, and so on. And when we implemented this functionality to collect data automatically, firefighters told us that they still want to option to enter data manually because they found this to be very useful during winter months. They enter some typical conditions for some area and start simulation and check what will happen if fire starts here in this condition and so on. And these are two examples. One is simulation start based on image ball. Start on real data. This simulation I started 2 months ago, so it was winter, high humidity, probably low wind and so on, and fire did not spread very much. However, if I enter data manually and set some typical summer conditions, this would be the outcome. So firefighters use this to prepare season in May. Confirmation procedure. This is standard procedure. So when you have an alarm, you click on alarm location. Location is shown on the map. Here you have, this is 7.5 kilometer bold line. This is some, I think, 15 to 70 kilometers from camera. Detection. When location is detected, operator starts fire spread simulation, and based on current weather conditions, and all of this information is provided to firefighters to guide intervention more safely. And field commander can access the system from its mobile phone or any other device to get a broader picture of the situation. So this is last step, starting simulation. And currently we have a system which is deployed at 74 locations in Croatia. Most of this location is, as expected, in coastal counties. However, due to climate change, we have some locations and more interest in continental part of Croatia, because year by year the fire hazard is higher and higher in these regions, and some of commercially most valuable forests are in these regions in continental counties. So this year we will add, I think, 3 more locations in northeast part of Croatia. This is just to show you current situation. These are all cameras and field of view computed based on camera height on 10 meters and smoke height on 10 meters. And this is a field of view of 4 cameras. We have 1 camera now here near Karlovac. And for this summer, I think 38 new locations are planned. That means almost 80 more new cameras covering coastal areas and some continental parts of Croatia. So thank you, that's all from me.